Fabrication of a pier is a complex process that involves several stages, including rebar fabrication, excavation, rebar installation, splicing, and concrete pouring. The following is an overview of each stage of the fabrication process. Rebar fabrication. Rebar, short for reinforcement bar, is a critical component of the pier's structural integrity. It is a steel bar or mesh of steel wires used to reinforce concrete and masonry structures. The first stage in the fabrication process is the fabrication of rebar. Rebar fabrication involves cutting steel bars into the required lengths and bending them into the desired shape. The bars are cut using a saw or a hydraulic shear, and then bent using a bending machine. The bending machine applies force to the steel bars, causing them to deform into the required shape. The shape and size of the rebar used in pier fabrication are determined by the structural design of the pier. The design specifies the number of bars, their diameter, spacing, and shape. Drilling and excavation. The next stage of the fabrication process is drilling and excavation. This involves drilling holes in the ground to create the foundation for the pier. The holes are usually drilled using a drill rig, which is a large piece of equipment that uses a drill bit to bore holes into the ground. Excavation involves removing soil and rock from the drilled holes to create a space for the pier's foundation. The depth and diameter of the holes depend on the structural design of the pier and the soil conditions. Rebar installation. Once the holes are drilled and the excavation is complete, the next stage is rebar installation. Rebar is placed inside the drilled holes to reinforce the pier's foundation. The bars are installed in a vertical position and are tied together using steel wire to create a framework. Splicing. Splicing involves connecting the rebar together to create a continuous framework. This is done by overlapping the bars and tying them together using steel wire. The overlap length depends on the structural design of the pier and the diameter of the rebar. Concrete pouring. The final stage in the fabrication process is concrete pouring. Once the rebar framework is complete, concrete is poured into the drilled holes. The concrete is poured in layers to ensure that it fills all the voids in the drilled holes and encases the rebar framework. The concrete used in pier fabrication is usually a high-strength mix with a compressive strength of at least 4,000 psi. The concrete is poured using a pump truck, which pumps the concrete into the drilled holes. After the concrete is poured, it is allowed to cure for a period of time, typically 28 days. During this time, the concrete hardens and gains strength. The curing process is critical to the pier's structural integrity and must be carefully monitored. The Shibushi Road No. 2 Bridge P3 Pier construction project is being carried out by Tensui Gumi Company, Limited in Japan. The project involves the construction of a cast-in-place pile foundation for the pier. The piles are being driven into the ground, and once the desired depth is reached, the hole is filled with concrete to form a solid foundation. The work is being done in place, which means that the piles are being driven into the ground without having to remove any soil or debris. This is done using a specialized drilling machine that is capable of creating holes of the required size and depth. The next phase of the project involves the reconstruction of the road leading to the bridge. This includes the excavation of the cast-in-place piles and the completion of the floor excavation. The road reconstruction work is being carried out in the Shibushi Road R312 construction section. The excavation work involves the removal of soil and debris from the site, and the excavation of the cast-in-place piles to expose the concrete foundation. Once this is done, the floor excavation work can begin. This involves removing any additional soil or debris to create a flat and level surface for the road to be constructed. The in-situ pile work includes the pile head processing and the completion of the pile. The pile head processing involves the removal of any excess concrete or debris from the top of the pile to ensure that the pile is level and flat. This is done using specialized equipment that is capable of removing the concrete and debris without damaging the rest of the pile. Once the pile head processing is complete, the pile can be finished. This involves the addition of any necessary reinforcing bars and the pouring of concrete into the pile to complete it. The concrete is poured in stages to ensure that it is properly compacted and that there are no air pockets or voids in the finished pile. The in-situ pile work is a critical part of the construction of the Shibushi Road No. 2 Bridge P3 pier and is essential for ensuring the stability and safety of the pier. The work is being carried out with the expertise of Tensui Gumi Company, Limited, and is expected to be completed successfully and within the designated timeline. The road reconstruction work in the Shibushi Road R312 section can proceed once the in-situ pile work is completed. Concrete beams are widely used in the construction industry for their high load-bearing capacity, durability, and low cost. However, they are susceptible to cracking under stress and tension, which can compromise their strength and structural integrity. To prevent cracking, steel stirrups are used as reinforcement in concrete beams. In this article, we will discuss the importance of steel stirrups in concrete beams and the different types of stirrups used in construction. What are steel stirrups? Steel stirrups are reinforcing bars that are used to provide additional support to concrete beams. They are bent in a U-shape and placed around the main reinforcing bars, also called the longitudinal bars, in a concrete beam. Steel stirrups help to distribute the load more evenly throughout the beam, reducing the risk of cracking and failure under stress. Importance of steel stirrups in concrete beams. Steel stirrups play a crucial role in reinforcing concrete beams and ensuring their strength and durability. Here are some of the key benefits of using steel stirrups in concrete beams. Prevents cracking. One of the primary benefits of steel stirrups is that they prevent cracking in concrete beams. When a beam is subjected to heavy loads, it can experience tension, which can cause it to crack. Steel stirrups hold the longitudinal bars in place and distribute the load more evenly throughout the beam, reducing the risk of cracking. Increases strength. Steel stirrups also increase the strength of concrete beams by providing additional reinforcement. The U-shaped stirrups are designed to resist shear forces, which can cause the beam to fail. By reinforcing the beam with steel stirrups, the strength and load-bearing capacity of the beam are significantly increased. Improves durability. Steel stirrups improve the durability of concrete beams by reducing the risk of corrosion. Concrete is a porous material that can absorb water, which can cause the reinforcing bars to rust and weaken over time. Steel stirrups act as a protective layer and prevent water from penetrating the concrete, reducing the risk of corrosion. Types of steel stirrups. There are several types of steel stirrups used in construction, each with its unique design and properties. Here are some of the most common types of steel stirrups used in concrete beams. Rectangular stirrups. Rectangular stirrups are the most common type of steel stirrups used in construction. They are made from a rectangular-shaped steel bar and are bent in a U-shape to fit around the longitudinal bars. Rectangular stirrups are easy to fabricate and are suitable for most types of concrete beams. Circular stirrups. Circular stirrups are made from a circular-shaped steel bar and are bent in a U-shape to fit around the longitudinal bars. They are commonly used in curved or circular concrete beams, as they can easily conform to the shape of the beam. Helical stirrups. Helical stirrups are made from a continuous steel wire and are wrapped around the longitudinal bars in a spiral pattern. They are used in concrete beams that are subjected to heavy loads and are designed to resist shear forces. Diagonal stirrups. Diagonal stirrups are used in concrete beams that are subjected to diagonal tension. They are made from a diagonal steel bar and are placed at an angle to the longitudinal bars to resist the diagonal tension.